Hello, I am Will Scott.
My name is Caleb Kennedy.
Unfortunately, our group member James Johnson couldn't be here. He is sick at the moment, but our project is an exoskeleton to reduce back strain in industrial applications. A little background on our project. Often, industrial workers are tasked with lifting very heavy objects. It can be boxes or machinery. And after enough exposure to these types of lifts, injuries can occur, like herniated discs and even sciatica. When these injuries occur, the employers have to pay workers' comp, and they are out an employee for months at a time. We found, or we decided, one solution to this was to apply an exoskeleton to the workforce. There is a lack of standards for testing protocols in this field. So we designed a procedure, a standardized procedure that can test and measure some of the uh, physical exertion from the user and the aid that the exoskeleton applies to the user. We chose a specific brand of a commercially available exoskeleton from HeroWare. We chose this due to its compact design and its aid while still allowing the user to avoid much muscle atrophy. Our problem statement is industrial workers complete repetitive tasks that can place strain on their body, specifically their back, leading to injuries that cause personal pain and financial hardships for both companies and employees. Bullard is a safety manufacturer interested in designing a setup and procedure to measure and identify exoskeleton effects, mainly back strain relief for industrial workers, to evaluate the market for commercialization and use for Bullard's own employees. The objective of our design was to create a standardized testing method for commercially available exoskeletons and obviously collect the relevant data necessary to evaluate the effectiveness of these exoskeletons in industrial applications. We're really looking for uh, a few things, one of them being a strain measurement system, another one being a system to obtain data from EEG, ECG, as well as temperature and humidity readings. We need to create a code for the circuit in order to obtain this. We're going to need to fabricate and assemble the circuit and housing unit. We will then test our design and provide a recommendation based on the test results.
To adequately test the effectiveness of exoskeletons, our design needed to include a variety of measurements. These types of measurements included load reduction, physiological measurements, and qualitative data. To measure the load reduction, we used flexible measuring tapes to measure the change in length of the elastic bands, which are the functional unit of the exoskeleton. Measuring the change in length will allow us to quantify the force that the elastic bands apply, which will reduce the perceived load of each lift. In terms of physiological measurements, muscle strain is one of the leading, one of the more prominent injuries, and this is due to overexertion of muscles. So we needed electromyography to target erector spinae muscles, which are the muscles involved in backlifting exercises, to measure the muscle activity with and without the exoskeleton. We also included physiological measurements of heart rate, body temperature, and humidity to quantify the overall physical exertion of these subjects. Finally, to obtain qualitative data, surveys were given to the subjects. As seen in figure 2, we have the measurement device placement. We have the ECG leads, which will monitor heart rate. And we have 6 pairs of electromyography leads targeting the erector spinae muscles, and 2 flexible measuring tapes to measure the deformation of the elastic bands. As seen in figure 3 is the wiring schematic of our setup. The central computing object is an Arduino Mega, and the temperature and humidity sensor is directly inputted into the Arduino, and the EMG and ECG leads will go into amplifiers and then into the Arduino, where the data will be processed and decisions will be made on the effectiveness of the exoskeleton. The bill of materials is composed of the electrical components that are needed to obtain the physiological measurements, as well as measuring tapes and weights to measure the deformation of the elastic bands. Also included in the bill of materials is weights to provide a standard lifting exercise for subjects.
The next steps in our procedure is going to be to build the prototype of the design circuit, construct the initial master code, and test the prototype and master code together using our proposed solution. After this, we will then make edits to the design or the code if any of them are needed. The focus of next semester is really going to be testing our procedure. We will gather the necessary data, make the correct recommendation, and solve the problem that is mentioned in our problem statement. This project couldn't be completed without the University of Kentucky, especially faculty members, Dr. Alicia Modenbach and Dr. Michael Peterson. It's financially supported by Bullard, and Bullard's representative has been a great help to us, Alyssa Kelly.